My name is Dr. Esther Trufan, and in today's experiment, we're going to use an unusual method to determine the density of an egg. For this experiment, we're going to use approximately 150 milliliters of our saturated sodium chloride solution, some deionized water, an egg, and because we're doing density determination, we're going to use a graduated cylinder, a scale, and just in case we need to add more water than we anticipated, we will be using a 400 and maybe even a 600 milliliter beaker. Let's have these in the reserve. For now, let's find out if our egg sinks or floats in our saturated sodium chloride solution. We're going to take it, place it in our solution, and we find that it floats, which means it is less dense than our saturated sodium chloride solution. Now, because between the egg and our sodium chloride solution, we're past 3/4 of the way full in the 250 milliliter beaker, I'm going to transfer its contents into a 400 milliliter beaker. I will extract my egg, transfer the sodium chloride solution, and place the egg inside. Next, I am going to add small increments of deionized water to achieve zero buoyancy. Zero buoyancy is achieved when the egg is barely submerged, but definitely not sinking to the bottom of the beaker. And this is a part where you can use a spoon or a stirring rod to mix your solutions and homogenize them as you add your water to your solution. If you're using a raw egg, you really want to be careful not to break it because otherwise it will make a massive mess. We can add a little bit more of our water, but we want to add small increments at a time to make sure that we are not going too far from concentrated to not so concentrated. It looks like our egg is slowly sinking, but we have not achieved zero buoyancy yet. And because the amount of solution that's in my beaker is increasing to such a point where swirling is inconvenient, this is a good time to get a stirring rod. The egg is still somewhat floating. Let's add some more water. The tip of the egg is still floating, so let's add some more water. You may want to slow down the additions here. It's pretty close, and we can add a little bit more water. And if this doesn't do it, then it is time to move into the next sized beaker. It's still floating, so let's take our 600 milliliter beaker, remove the egg from our solution, pour over the solution, set the beaker to the side, and lower the egg inside the solution. It's barely floating, but it is still floating, so let's add some more water. We are very close to zero buoyancy, so this is a part where we really need to be patient and go in small increments, because if we go a little bit too generous with our deionized water, it is very easy to lower our density so far that our egg sinks to the bottom. And I think we are very, very close. And this is how we achieve zero buoyancy. It's not sitting at the bottom of our beaker, and it is not floating to the top of the beaker, but it is rather settled somewhere in the middle. At this point, we can say that we achieved zero buoyancy, which means the density of our egg and the density of our saltwater solution is exactly the same. And if we establish this equivalency, then we can use our previously adopted measurements on determining the density of liquids to determine the density of our solution, and with that, the density of our egg. We can extract our egg. Set it aside. Bring in our scale. Turn it on. Place our graduated cylinder on top. Tear it. Pour into it between 15 and 20 milliliters of solution. Record the mass. It is 20.20 grams. And then as we take off the graduated cylinder, we record the volume, which is 19.3 milliliters. From the mass and the volume of our solution, we can determine its density, which we now know is the same as the density of our egg.